Hello everyone. Today we are going to see the topic surface area and volume exercise 13.1. In your previous classes like 9 we learned the basics of the surface area and volume. Here we are going to see the combination of solids. Right. For that particular figure we are going to find the surface area. For an example, see here we are having a figure, right? So this figure is the combination of two hemispheres and one cylinder. Okay, so this is a combination of two hemispheres and one cylinder. See, this is the figure. So it is the combination of two hemispheres and one cylinder. So how we are going to calculate the surface area of this figure means, see, the total surface area of a new solid means nothing but the whole figure, is curved surface area of one hemisphere. See, this is one hemisphere and this is another hemisphere, right? So we are going to find the curved surface area of one hemisphere plus this curved surface area of a cylinder plus curved surface area of the another hemisphere, right? If you add these three, you will get the whole figure. So this way we are going to find the surface area of the combination of solids. Next, another example I have given here. What is that? Here this is the actual figure, right? It is a toy, and this toy is the combination of two figures. What are all the two figures means? One is 4, another one is hemisphere, right? Hemisphere is nothing but half of the sphere, right? So if we combine these two figures, we will get this exact toy. So how we are going to find the surface area? So the total surface area of the toy is equal to curved surface area of a hemisphere plus curved surface area of a cone. Then we will get the total surface area of the particular toy, right? So these are all the basics. Our exercise 13.1, right? So two cubes, each of a volume 64 centimeter cube, are joined end to end. Find the surface area of the resulting cuboid. See, in the figure you can see this is one cube. Now I am highlighting. This is one cube. Okay, this part. And this part is another cube. Okay, these two cubes, they are joining with end to end. So this is the place where they are joining. So they are joining two cubes and the final figure is a cuboid. This final figure is a cuboid. So now what they are asking, find the surface area of the resulting cuboid. So now we are having a cuboid with the combination of two cubes. They are joining two cubes and we are getting a cuboid. So first we have to find the area of those things. So listen. So here they have mentioned that volume of each cube is 64 centimeter cube. They have mentioned. So with that we can find the side, isn't it? So volume of the cube is A cube is equal to 64. So A is equal to cubic root of 64, isn't it? The cubic root of 64 means A will be 4. 4 fours are 16, 16 fours are 64. So we got the value of A. So the side is 4 centimeter. Okay. Here we got the cuboid. Right. We got the cuboid. So the length and breadth of the resulting cuboid will be 4 centimeters. If you see, you can find it out. Your length and breadth will be 4 centimeter, and for cuboid height we have to calculate. If you see here, right, this is one cube and this is another cube. So this is 4 centimeter and this is 4 centimeter, overall 8 centimeter. So we know the formula to find the surface area of a cuboid. What is our formula? 2 into 2 into LB plus BH plus HL. So this is our formula to find the surface area. We are having every values. Length we are having, breadth we are having. So what we are going to do? We are going to substitute every values. So while substituting and simplifying, we are getting 160 centimeter square. So this is our surface. This is the surface area of the cuboid we have to find. So now our second question is, a vessel is in the form of a hollow hemisphere. A vessel is in the form of hollow hemisphere mounted by a hollow cylinder. See the figure carefully, then you will be able to understand. It is a vessel, right? Hollow hemisphere. See, this particular area will show the hemisphere mounted by a hollow cylinder. It is mounted by a cylinder. A cylinder is here. Okay. So now the diameter of the hemisphere 14 centimeter and the total height they have given, overall height, not they did not given like for cube, for cylinder, like that separate they didn't give. The overall height is 13 centimeter. Find the inner surface area of the vessel. We have to find the inner surface area. So here first let we noted down what are all the things they have given. First, the diameter of the hemisphere, which is 14 centimeter. So with the diameter we can find the radius of the hemisphere, which is 7 centimeter. Right. Now height of the cylinder, we have to find it out. See, I'll explain you here. This is our figure, right? So this is our figure. In this figure, radius of the hemisphere is 7 centimeter, right? Radius of the hemisphere will be 7 centimeter, and we have to find the height of the cylinder. Overall height is 13 centimeter. Overall, the full figure. The height of the full figure is 13 centimeter. Here we are having. Here the radius is 7 centimeter, which means for this hemisphere we can calculate it as 7, right? Overall 13. So 13 minus 7 will gives you 6, which is the height of the particular cylinder. Clear? So height of the cylinder we are having. And the radius of the hollow hemisphere, radius we know 14 by 2 will give you 7. Now the inner surface area of the vessel, how we can find? Curved surface area of a cylinder plus curved surface area of a hemisphere. That's it, because these two figure only we are having. So one is curved surface area of a cylinder, another one is curved surface area of a hemisphere. So we know the formula. For first cylinder is 2 pi RH and for hemisphere 2 pi R squared. So substitute in these two, which is common, 2 pi R is common, remaining is H plus R. 2 pi R into H plus R. Substituting the value and simplifying, we are getting 572 centimeter square. Nothing. Here we are having two shapes. One is cylinder, another one is hemisphere. So we are going to add the curved surface area of a cylinder part plus hemisphere part. Then we will get the total area of that particular vessel. Third question. A toy is in the form of a cone of radius 3.5 centimeter. See the figure. In this figure, toy is in the form of a cone. Right? This cone radius they have given 3.5 centimeter mounted on a hemisphere. So here we are having hemisphere. In the hemisphere, it mounted as a cone. Right? This is the toy. Like our previous problem, here they have given the total height. Find the total surface area of the toy. We are going to find the total surface area of the toy. So now listen. Here they have given radius of the cone, which is 3.5 centimeter. See, here radius of the cone and hemisphere they have given 3.5. Now the total height of the toy is 15.5. Like, remember the previous problem. Previous problem, what was there? Cylinder and the hemisphere, right? So here cone and the hemisphere. What we are going to do? What is the radius? Radius is 3.5. Total height is 15.5. So 15.5 minus 3.5 will give you the height of the cone, which is 12. Clear? So height we got, radius we know, but what is the formula to find the curved surface area of a cone? Pi r L, right? L we have to find. So you know the formula to find the value of L. How we can find? Square root of h square plus r square. H value we know, r value we know. We are talking about the cone. Okay? So the height of the cone is 12 plus 12 square plus radius is 3.5 square. So while simplifying, we are getting 25 by 2. This is the slant height, means L of the cone. So now we are going to find the curved surface area of the cone, pi r L. So instead of pi 22 by 7 into radius 7 by 2. Why we are keeping 7 by 2? For easy to cancel. Otherwise 3.5 directly you can keep. 7 by 2 into L we found just now, which is 25 by 2. So while simplifying, we are getting 275 by 2 centimeter square. This is curved surface area of the cone. So this first part is over. Next, this below part, which is hemisphere, we have to find. So the curved surface area of a hemisphere formula is 2 pi r square. So 2 into 22 by 7 into r square, 7 by 2 the whole square. We are getting the value of 77 centimeter square. Right? Separate we found the curved surface area, but we want the total surface area of the particular toy. So your fourth question, a cubical block of size 7 centimeter is surmounted by a hemisphere. What is the greatest diameter of the hemisphere can have? Greatest diameter, what will be they are asking? Find the surface area of the solid. So first, total surface area of the solid. What are all the two figures here? Here they are having a cuboid plus it is surmounted by the hemisphere. So here total surface area is your surface area of the cuboid block. What is your cuboid block? This particular thing. So this cuboidal plus this hemisphere, right? But here there is no need to involve the base of the hemisphere. Because of that reason only, we are subtracting the base area of the hemisphere, which means pi r square. So 2 pi r square minus pi r square will be pi r square. That's what we did here. 6 into side square plus 2 pi r square minus pi r square, pi r square. Here this is the formula we need. Now we are going to substitute everything because side they have given 7 and radius we know that 7 by 2. But this is a diameter. So radius means 7 by 2. So we are substituting everything and simplifying. We are getting 332.5 centimeters square. Now, fifth question. A hemispherical depression is cut out from one face of a cubical wooden block. There is a cubical wooden block. From that, hemispherical size, they are cutting out from one face of the cubical wooden block. The diameter L of the hemisphere is equal to the edge of the cube. See, here only they have mentioned diameter L of the hemisphere. Diameter of the hemisphere, this is the diameter of the hemisphere, is equal to the edge of the cube. Right? They have given this. Now we are going to determine the surface area of the remaining solid. So first, what are all the things they have given? Diameter of the hemisphere is equal to the edge of the cube, which is L. They have given. So now diameter is L means what is the radius? L by 2 is your radius. So L by 2. Next, total surface area. Total surface area of the solid. We need the total surface area. How we will find? First, surface area of the cube. So here we are having the cube. So first we have to find the surface area of the cube plus curved surface area of a hemisphere. So this is our hemisphere. So the curved surface area we have to find. Like our previous problem, we don't want the base of the hemisphere. We don't, because the base area only we are cutting out from the cube. So there is no need of base. So subtracting the pi r square. That's it. So what else is there? First, surface area of a cube, which is 6 into edge square. So 6 into edge we know, which is L square, plus 2 pi r square minus pi r square, which is here. So 6L square plus pi into R we know L by 2. So L by 2 the whole square. What we will get? 6L square plus pi L square by 4. Here what we can take it out means L square by 4. So we are having 24 plus pi. So this is our required surface area of the remaining solid. So next question, 8th question. From a solid cylinder whose height is 2.4 centimeter and diameter is 1.4 centimeter, a conical cavity of the same height and same diameter is hollowed out. Find the total surface area of the remaining solid to the nearest centimeter square. See, there is a solid cylinder is there. See the figure. There is a solid cylinder is there here. Solid cylinder is here, right? That height of the cylinder they have given that 2.4 centimeter and the diameter is 1.4 centimeter. Here in the shape of cone they are going to cut out from the cylinder. Now we have to find the remaining thing, right? So now listen, the diameter of the cylinder, obviously it will be equal to the diameter of the conical cavity. That cone be fixed there. Both the diameter will be equal, which is 1.4 centimeter. So if diameter equal means radius will also be equal. 1.4 divided by 2, you will get 0.7. Now height of the cylinder, which is 2.4 centimeter they have given. Now we are going to find the total surface area of the remaining solid. How we are going to find the total surface area? Surface area of the conical cavity, that surface area, plus total surface area of the cylinder. Both if we add, the full figure we will get, right? For whenever we are taking about cone, cone means definitely slant height we need, L. So slant height, how we will find? You know the formula, square root of h square plus r square. So h, we know the value of h, which is 2.4 square plus r, which is 0.7 square. While simplifying, we are getting 2.5 centimeter, which is slant height, L. Now we are going to substitute in the formula, right? surface area of a conical cavity plus total surface area of the cylinder. So pi RL plus 2 pi RH plus pi R square. Right? For this cone we are taking 2 pi RH plus pi R square. So here what commonly we can take it out, is pi R we will take it out, L plus 2H plus R will be there. Substitute the value and when we are substituting the value, what we are getting, 17.6 centimeter square we are getting, right? Thank you so much for watching the video. The next exercise we will see in the next video. Thank you.